Welcome to VP's Math Solution. It's your Premalata Vasudevan here. In this video, we are going to discuss Fourier series till odd and even function children. Rest of the things like half range, complex, and harmonic we'll see in the next video. Even Parseval's identity was included in this video, children. Now, you have already come across these two integral, right? Integral e power ax sin bx dx and integral e power ax cos bx dx. You have to remember this to do problems or express a function like e power ax as a Fourier series. Now, this is Bernoulli's integration by parts formula. Integral uv dx equal to u v1 minus u dash v2 plus u double dash v3 minus so on with alternative plus or minus like u dash is derivative of u double dash is derivative of u dash, and v1 is integral of v, and again if you integrate v1 it is v2, like that it is going on. Then two more important trigonometric results are sin n pi is 0, right, if n is an integer. Similarly, cos n pi is minus 1 whole power n if n is an integer. Then these three rest of the trigonometric, right, results you will be knowing it. So just keep it in mind while doing the problems. Now, Fourier series. The sufficient condition for a function f of x to be expressed as a Fourier series is the condition is also known as Dirichlet's condition, right? It will be asked for 2 mark question in any university question paper, right? Like it should be periodic, single valued and finite in the interval in which it is going to be expressed. And also it should have only finite number of discontinuities, no infinite discontinuities. And finally, it should have only finite number of maxima and minima. Now, children, the Fourier series is used to express periodic functions which occur commonly in physical and engineering problems in a series of sines and cosines, right? So now we are going to see the Fourier series in the interval c comma c plus 2l. Now what is the interval length, children? It is 2l. Now what is f of x? Fourier series for f of x is a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by l plus summation n equal to 1 to infinity b n sin n pi x by l. Your a naught is half the length of the interval. The interval length is 2l. Half the length is l. So 1 by l c to c plus 2l f of x dx. Then a n is 1 by l c to c plus 2l f of x cos n pi x by l into dx. Then bn is 1 by l integral c to c plus 2l f of x sin n pi x by l into dx, children. Now, same thing, right? Same Fourier series in the interval 0 to 2l. That means your c is 0 here, right? The rest of the things are the same except the limit. It will be 0 to 2l. See here, all the other things were the same. F of x is equal to a naught by 2, then summation plus summation n equal to 1 to infinity a n cos n pi x by l plus summation n equal to 1 to infinity b n sin n pi x by l. Also a naught, a n, b n are all same except the limits. The limits are 0 to 2l because c takes the value 0 here, right? Then here also the length of the interval is 2l, so half the interval 1 by l you are taking now. Now we are getting into the next case. Fourier series in c comma c plus 2 pi. What is the length of the interval? It is 2 pi. See here, upper limit minus lower limit. C plus 2 pi minus c is 2 pi. Half the length is divided by 2, it is pi. So wherever it is l, here you are going to replace l by pi. See, so if you replace l by pi, pi will be getting cancelled. All n pi x by l will become nx, right? So here also pi will be getting cancelled, children. So a naught by 2 plus summation n equal to 1 to infinity a n cos nx plus summation n equal to 1 to infinity b n sin nx. And then all the Fourier coefficient a naught, a n, b n and all, l is pi. So 1 by pi c to c plus 2 pi integral is f of x dx. Again, an is 1 by pi, integral c to c plus 2 pi, f of x into cos n x dx. Bn is also 1 by pi, integral c to c plus 2 pi, f of x sin n x into dx. Now, again, you are going to discuss Fourier series in the intervals 0 to 2 pi. Same thing, case 2 as such, except c is 0. So, now c is 0. So, you are going to replace c by 0. So, 0 to 2 pi. Other than that, it is same like this because the interval length is 2 pi. Half the length L is equal to pi. Wherever it is n pi x by L, you are going to replace it by pi. So, what will happen, children? If you replace it by pi, pi will be getting cancelled. It will become cos nx. Same thing. So, then now, Fourier series in the interval 0, 3, not only 0, 3, 0, 6, 0, 5, whatever it is, you are going to find the half the length of the interval, L equal to upper limit minus lower limit divided by 2. So, 3 minus 0 by 2, it is 3 by 2. So, 1 by L will be 2 by 3. N pi x by L will be n pi x divided by 3 by 2. So, 2n pi x by 3, children. So, same as such, here the first case, wherever it is n pi x by L, it will be replaced by 2n pi x by 3. That's it. Other than that, it is the same. So, f of x is a naught by 2 plus summation n equal to 1 to infinity a n cos 2n pi x by 3 plus summation n equal to 1 to infinity bn sin 2n pi x by 3. And then the Euler constants or Fourier coefficients are a naught is 1 by L. 1 by L is 2 by 3. 2 by 3, 0 to 2L. What is 2L is 3. So, 0 to 3 f of x dx. Similarly, your an will be 2 by 3, 0 to 3 f of x cos 2n pi x by 3 into dx. As such, your bn is 2 by 3 integral 0 to 3 f of x sin 2n pi x by 3 into dx. Whenever a problem is posted to you, first you should know how to write the Fourier series for the given interval. Right? This will yield you 1 or 2 mark in the exam. Now, Parseval's identity. If a Fourier series corresponding to f of x converges uniformly to f of x in the interval c, c plus 2l, then 1 by 2l integral c to c plus 2l f of x the whole square dx equal to a naught square by 4 plus 1 by 2 into summation n equal to 1 to infinity an square plus bn square. In both sides 1 by 2 is common, so we were cancelling it and then we are getting the remaining what is a identity, Parseval's identity. Then convergence condition. Children, Parseval's is very easy. Convergence, right? You try to do it. The Fourier series of f of x converges to f of x at all point where f of x is continuous. That is, the sum of the Fourier series of f of x converges to a value of f of a at the continuous point x equal to a. If it is a continuous point, then f of x converges to f of a. That is what they are saying. If it is a discontinuous point, then it is nothing but it will converge to the average of left and right limit at that point. Okay, while doing problems, you will be understanding this. Now, first problem. Obtain the Fourier series for f of x equal to x square in the interval 0 to 2 pi. So, we have come across if it is 0 to 2 pi, L is pi. So, n pi x by will become nx. So, your Fourier series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. So, what is your a naught is? 1 by pi integral 0 to 2 pi f of x dx. Your f of x is x square. Integration of it is x cube by 3. You are applying the upper limit minus lower limit. You are getting the a naught value as such. Then your an 1 by pi 0 to 2 pi f of x cos nx dx. So, what is your u? What is your v? U is algebraic function. So, it is x square, v is cos nx. See, u v1, u dash v2, u double dash v3, minus so on it is with alternative plus or minus. So u is x square you are writing here, right? Then v is you have to integrate cos nx. If you integrate cos nx, it is sin nx by n. Again, x square you have to differentiate because u dash. X square differentiation is 2x. Then v2. You have to integrate v1 and then you have to put here. So sin nx integration is minus cos nx by n. Already one n is there. So minus cos nx by n square. Then again you have to differentiate this u dash. U dash is 2x here. If you differentiate it is 2. Then integrate this v2. It is cos integration is plus sin nx by n. Already minus 1 by n square is there. So minus sin nx by n cube, children. Already I have told you sin n pi is 0. So 2n pi is also 0. 3n pi is also 0. Sin of. So sin 0 is 0. But cos 2n pi is 1. By that sin will become 0. Sin 2n pi is also 0. Sin 0 is also 0. So first term, third term will be 0. We are going to apply the limit for the second term. So if you apply this minus of minus, it is plus. So you are applying the upper limit. Minus 2 into 0 is 0. So 0 into anything is 0. You are getting your an as such. Children, keep it in mind. Why I am putting the bracket is, see, minus cos nx. You are not supposed to club this negative with this negative, right? So that if you club this cos nx, you will write here as plus sin nx by n cube. To avoid that, just put within bracket, right? Even if you put u dash also within bracket, it is well and good. Okay, then you have to find bn. Last step is before substituting into f of x. So bn is 1 by pi, 0 to 2 pi, f of x sin nx dx. What is your u is? F of x is x square. That is your u. Sin nx is your v. So first u v1. U is x square. v1 is integrate sin nx. It is minus cos nx by n. Minus, right? Because the formula is minus with alternative plus or minus. U dash. Differentiate this x square. It is 2x. Integrate this term. It is minus sin nx by n square. Cos nx is plus sin nx by n only. Integration value is. But already minus 1 by n is there. It is added along with it. Plus. Differentiate this 2x. It is 2. Integrate this. Sin nx integration is minus cos nx. So minus of minus, this will become plus cos nx divided by n. Already this n square is there. So along with it, it is n cube. As usual, sin 2n pi is also 0. Sin 0 is also 0. So second term vanishes. Then you are applying the limits for the first and third term. So applying wherever it is x, you are applying 2 pi. So 2 pi square cos 2n pi, then 2 cos 2n pi by n cube. Then if you apply 0, 0 into anything is 0 plus that is minus lower limit, isn't it? Minus 2 times cos 0 by n cube. Now cos 2n pi is 1. So this will become minus 4 pi square by n. This will be 2 by n cube. Cos 0 is also 1. This will be minus 2 by n cube. So 2 by n cube, 2 by n cube will be getting cancelled. This is your bn. So you have to substitute a naught, an and bn value in equation 1. Equation 1 is nothing but, right, your this one. This formula is equation 1. In this, you are going to substitute to get the required Fourier series for the function x square. So you have substituted a naught by 2. So you are substituting a naught plus summation n equal to 1 to infinity bn value you are substituting into cos nx. Then again an value it is 4 by n square you are substituting plus summation n equal to 1 to infinity bn value you are substituting into sin nx in the interval 0 to 2 pi. Now what is your f of x is? Your f of x is x square, children. So x square is expressed in terms of sine and cosine, right, series. in the interval 0 to 2 pi. Now next one. Express f of x equal to e power x as a Fourier in, or as a Fourier series in, right? This can be, what to say children, it can be Fourier series in 0 to 2 pi. Now what you are doing is, you people as a Fourier series in 0 to 2 pi. So 0 to 2 pi, your f of x is this. Your required Fourier series is this. A naught by 2 summation n equal to 1 to infinity a n cos n x plus summation n equal to 1 to infinity b n sin n x. You have to find your a naught. A naught is 1 by pi 0 to 2 pi f of x dx. So f of x is e power x. Its integration value is e power ax by a. You are applying upper limit minus lower limit. So lower limit e power 0 is 1. So you are getting a naught as like this. I told you in the as a standard integrals, I gave you 3 formulas along with Bernoulli's integration by parts. Right? I asked you to remember this to evaluate, to express exponential functions as a Fourier series. So now an is 1 by pi 0 to 2 pi f of x is e power ax cos nx dx. Now just compare these two formula, right? Instead of b, right, you have n here. So in this formula, wherever it is b, put n. Then apply upper limit minus lower limit, children. You all know sine 2n pi and sine 0 or 0. So remaining you are getting as such. Take commonly outside a by pi into a square plus n square. It is inside the bracket, it will be e power 2a pi minus 1. That's it. To find bn, again 1 by pi integral 0 to 2 pi f of x sin nx dx. E power ax f of x is sin nx dx. Again compare this with this formula, standard integral formula. Then here instead of b it is n. So what to say, wherever b you just write n here, apply upper limit minus lower limit. Wherever you have x, apply 2 pi first. Then wherever you have x, apply 0 as a lower limit. In between you will be having a negative sign. Then sin 2n pi and sin 0 are 0. So remaining terms take commonly outside, you will be getting bn as such. So substituting a naught, an, bn in the Fourier series which you wrote first, 1, equation 1. And then that will be your required Fourier series for e power ax in the interval 0 to 2 pi, children. Now first time we are going to come across, what is this convergence condition, right? We are going to deduce this series. You always keep it in mind, the value for 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on, whatever the problem may be, the answer will be the same, right? If at all I am not wrong, it is pi square by 8, I hope so. Oh, yeah, see, it is pi square by 8. So whatever the problem is, if they give this series, your value is pi square by 8. Now find the Fourier series of period 2 pi for the function f of x. Value is 1 in the interval 0 to pi, 2 in the interval pi to 2 pi. Hence deduce these two series they have given. So 0 to 2 pi means as usual your Fourier series is this. Right? We have come across case 1, case 2 in the beginning. Then you have to find your a naught. What is a naught is 1 by pi 0 to 2 pi f of x dx. But here 0 to 2 pi you cannot substitute one function. It is splitted from the function is 1 in 0 to pi, 2 from pi to 2 pi. So you have to split this into two integrals, 0 to pi, pi to 2 pi. Here it is 1, here it is 2. You are integrating dx integration is x, applying upper limit minus lower limit. You are getting your a naught value, children. Similarly, an is 1 by pi 0 to 2 pi f of x cos nx dx. Here again we are splitting it the interval into 0 to pi plus pi to 2 pi, and then we are applying f of x value 1, 2 respectively in both the first and second integral. Then you are getting cos nx. Cos nx integration is sin nx by n. We all know sin n pi is 0, sin 0 is 0, also sin 2n pi is 0. So your an value is 0 children. Next, your bn ma. Your bn is 1 by pi integral 0 to 2 pi f of x sin nx dx. Again split this into two integral 0 to pi plus pi to 2 pi. Substitute f of x values. Then we are getting only sin nx to be integrated. Sin nx, if you integrate, it is minus cos nx by n. Right? Here also you will be having this 2 commonly outside. Substitute upper limit minus lower limit. Cos n pi is minus 1 whole power n. Cos 2 n pi is 1. Cos 0 is 1. So you are just writing all this value. See, 1 by n minus 2 by n is minus 1 by n. Then 2 minus 1 whole power n by n minus 1 whole power n by n. So it is plus minus 1 whole power n. So you'll be getting like this. Now children, this is a new thing we are coming across here. When n is even, what will happen? N is 2 for an example. Minus 1 whole square is 1. 1 minus 1 it is 0. Whatever n value is, it should be even. 2, 4, 6, whatever it is. It will be, the first term is plus 1, minus 1 is 0. If it is odd, n is odd, what will happen ma? The first term will be minus 1. Minus 1, minus 1. If you add, it is minus 2 divided by n pi. So substitute a naught, a and b n value in equation 1. So you will be getting the, what is it ma? Fourier series like this. So this is defined only for odd function, isn't it? Otherwise it is 0 for even function. So we are writing this as n equal to 1, 3, 5, so on till infinity like this. Otherwise what you can do is, you can write summation n equal to 1 to infinity, but 1 by 2n minus 1, odd number. See, substitute n equal to 1, it is 1. Substitute n equal to 2, 4 minus 1 is 3. Substitute n equal to 3, 6 minus 1 is 5. So it is the same, right? So wherever it is n, you are replacing it by 2n minus 1 and you are writing n equal to 1 to infinity. Both are, what is ma? Equivalent only. Otherwise, you can just, what is ma? Express this, substitute the values. You can take minus 2 by pi outside, isn't it? Then substitute n equal to 1, it is sin x by 1. Put n equal to 2, it is sin 3x by 3. Put n equal to 3, it is sin 5x by 5, plus so on it will be. We are going to deduce the first part, right? See children, what you have to do is 1 minus 1 by 3 plus 1 by 5 minus, it is going on as such. That convergence condition I told you, isn't it? It will converge either at the endpoints maximum, either at the endpoints or in the midpoint, right? So we are taking, it is from 0 to, what is ma? 0 to pi, pi to 2 pi. So what we are doing is, we are going to take pi by 2. Why? Because sin pi by 2 is 1, sin 3 pi by 2 is minus 1, sin 5 pi by 2 is 1. Likewise it goes on. So we are going to choose x equal to pi by 2. It is a point of continuity, right? So the sum of the Fourier series converges to, f of x converges to f of pi by 2 directly. F of pi by 2 means, you see where pi by 2 lies, here the pi by 2 lies between 0 to pi. So f of x value is 1. So your f of pi by 2 is 1 children. You are substituting 1. Then as it is, at x equal to pi by 2, left hand side is 1. Here wherever it is x, you are applying pi by 2. As I told you, sin pi by 2 is 1, 3 pi by 2 is minus 1, 5 pi by 2 is 1, so on it goes on. Now you take this to the other side, so it is becoming 2 by pi. Then this 3 by 2 minus 1 it will be, take minus 1 to the other side. Then if you simplify, you will be getting this value children. Then when to use Parseval's identity, you should know. See here ma, in your an, bn, what you are having, an is 0. Your bn, you have 1 by n, right? Suppose they are having the square of it, asking the square of it, like 1 by 1 square, 1 by 3 square, you have to go for Parseval's identity. If it is 1 by n square in bn, they'll be asking 1 by n power 4 in the deduction part. You understood? So now you have to go for Parseval's identity children. It is 1 by pi, 0 to 2 pi, f of x the whole square dx, a naught square by 2 plus summation n equal to 1 to infinity, a n square plus b n square. First, we'll take the right side to be the left side here. This is a naught square is 3 square by 2 plus. It is, what is Emma? An is 0 here. So 0 square. Then Bn is defined only for the odd numbers. Minus 2 by n pi, the whole square. Then here, the left hand side, you have to split it between 0 to pi and pi to 2 pi. 0 to pi, it is 1 square. Pi to 2 pi, f of x is 2. So it is f of x the whole square will be 2 square 4. You are integrating the integral dx. It is x. You are applying upper limit minus lower limit. You are getting it to be 5. Left hand side, it is 3 square by 2 is 9 by 2. You are taking this 4 by pi square outside. You are expanding it by applying n equal to 1, 3, 5, so on. You are getting as such. Then you are simplifying the right side. Then you are taking this 4 by pi square to the other side. It is coming to be pi square by 8, children. The next question, fourth question is, obtain the Fourier series for f of x of period 2L and defined as follows. It is L minus x in 0 to L, 0 in L to 2L. They are asking for two deductions, right? First, it is, what is Emma? 0 to 2L. What is the half the interval length is L. So, your Fourier series will be like this. A naught by 2 plus summation n equal to 1 to infinity. An cos n pi x by L plus summation n equal to 1 to infinity. Bn sin n pi x by L it will be, right? So, A naught is 1 by L, 0 to 2L, f of x dx. So, f of x you'll be splitting between 0 to L and L to 2L. L to 2L, f of x value is 0. So, integrand is 0. So, the integral value is 0. This you are integrating as Lx minus x square by 2. Applying upper limit minus lower limit, you will be getting this value, children. Then similarly, An. 1 by L, 0 to 2L, f of x cos n pi x by L into dx. So, you are splitting it into two integrals, 0 to L, L to 2L. Second integral will be 0 because your f of x value is 0. Here in the first integral, f of x is L minus x. That is your u. The second one is your v. So, u v1. L minus x, integrate cos, it is sin n pi x by L divided by whatever the coefficients of x, n pi by L, you have to put it in the denominator. Minus, differentiate this ma, u dash. U you have to differentiate. So, u dash is, L differentiation is 0 minus 1. So, 0 minus 1 it is minus 1. Again integrate sine. Sine integration is minus cos n pi x by L divided by n pi by L. Already one n pi by L is there. So, the whole square. Again, apply x equal to L, children. Here, if you apply L will be getting cancelled. It will be sin n pi. Apply the lower limit, x equal to 0, sin 0 is 0. The first term is vanishing, it is 0. Second term, negative into negative into negative, it is negative. Take this to the, what is Emma? Left hand side as L square by n square by n square pi square. So, you will be having minus cos n pi x by L, apply the limit. So, it is minus cos n pi plus cos 0. Again, here what you are getting is 1 minus 1 whole power n. Suppose n is odd, what will happen ma? It will become minus 1. Minus 1 whole power n will be minus 1. So, minus of minus it is plus. So, it is 2. So, 2L by n square plus pi square when n is odd. When n is even, what will happen, children? This will become plus 1. 1 minus 1, it is 0. So, it is 0 when n is even. Again, you are going to find Bn 1 by L, which is nothing but 1 by L, 0 to 2L, f of x sin n pi x by L into dx. You are splitting this into two integrals, 0 to L and L to 2L. In the second integral, f of x value is 0. Second integral is 0 because the integrand is 0. Then you are evaluating the first integral by Bernoulli's integration by parts. It is u v1 minus u dash v2. L minus x, differentiate it is minus 1. Sin n pi x by L, integrate it is minus cos n pi x by L divided by n pi by L. Cos integration is plus sin by n pi by L. But already minus by n pi by L is there. So, minus sine n pi x by L divided by n square pi square by L square. If you apply x equal to L, L will be getting cancelled. It will be sine n pi. Apply x equal to 0, it is sine 0. So the second term is 0 because of the results. So you are just applying the limit for the first term. So L minus L, it is 0. So upper limit is 0. Minus of minus plus. Lower limit is L minus 0 cos 0. It is L by n pi bn is. You have to substitute a naught, an, bn in 1. So you will be getting the term like this, a naught by 2, because a naught is L by 2 divided by 2 is L by 4. Then summation an cos n pi x by L plus summation bn sin n pi x by L. We are substituting an, bn here. Then again, what is the first one is, see, according to this, you have to select the point. 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 likewise. So you have to concentrate by 1 by n. That is, what is Emma? Here, you have to consider this one. The second term you have to consider. This should become 0. So when it will be 0? If you put cos n pi by 2 is 0 when n is odd. Cos n pi by 2 is 0 when n is odd. So it is possible when it will be cos n pi by 2, x should be L by 2. So x equal to L by 2 is a point of continuity. So f of x converges to f of L by 2. So what is your L by 2 is where it lies between here. 0 to L. L by 2 lies between. So L minus L by 2. It is L by 2. The value is. So you are getting the left hand to be L by 2. At x equal to L by 2, the second equation becomes wherever it is x, you put L by 2. Cos n pi by 2 is 0 when n is odd. So sin n pi by 2 you will be having, right? So you just express this, right? It is like L by pi you will be taking outside. Sin n pi by 2 by n it is. So you go as n equal to 1, 2, 3, so on. When n is 1, sin pi by 2 is 1. When n is 2, 2 will be getting cancelled. Sin pi is 0. When n is 3, sin 3 pi by 2 is minus 1. Likewise, you will be having the terms like this. L will be getting cancelled from both the sides. Right? It is common in both the sides. Then the remaining is like this. Then next one is, you have here n square is this. Second one deduction is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. So you have to concentrate the second term. It should exist. This term should vanish. The second sign should vanish. So you are substituting x equal to L. So your f of x is 0. See here at x equal to L it is L minus L also 0. Here also 0 it is. So what you are doing is the left hand side is 0. Then at x equal to L you are substituting x equal to L. You are getting like this. Cos n pi is minus 1 whole power n. Right? Sin n pi is 0. You are taking rest of the terms to the right side. And then you are simplifying. You are getting this. That's it. Last question in this part in 0 to 2L or otherwise interval 2L or 0 to 2L or 0 to 2 pi. In that case, your interval is 0 to 3. Right? Your f of x is this. You have to find the Fourier expansion for it. So as we already discussed in the last case, upper limit minus lower limit divided by 2 is your L. So 3 minus 0 by 2 is 3 by 2. Okay. 2L is 3. Keep it in mind. 2L is what? 3. So you are writing this. Cos n pi x by L it should be. L is 3 by 2. So 2 is going to the numerator. Cos 2n pi x by 3. Similarly, a naught is 1 by L, 0 to 2L f of x dx. 1 by L is 2 by 3. Right? 0 to 3 f of x dx. You are substituting f of x. You are integrating. You are applying upper limit minus lower limit. You are getting the a naught to be 0. Your an 1 by L, 0 to 2L f of x cos n pi x by L dx. Your L is 3 by 2, 2L is 3. You are substituting that, right? Here wherever L and 1 by L are, then you are integrating it. This is u, v. U is 2x minus x square. Here up first term minus second term plus third term. Likewise it goes on with alternative plus or minus. Here 2x minus x square. Differentiate this. 2 minus 2x. Again differentiate. It is minus 2. Now you have to integrate cos. It is sine 2n pi x by 3 divided by except x. Whatever the coefficients are, you have to put it in the denominator. Then here V2. You have to integrate this and you have to substitute here. So integration of sine is minus cos divided by this square 2n pi by 3 the whole square. Again you have to integrate this. Integration of cos is plus sine divided by 2n pi by 3. Already this exists. So minus divided by 2n pi by 3 the whole cube. So 8n cube pi cube by 27 children. Here if you apply 3, upper limit as 3. Here x if you apply 3, 3 will be getting cancelled. It will be sine 2n pi. If you substitute 0, sine 0 will be 0. So first and last term will be 0. You have to apply limit only for the second term. So apply 3, that is upper limit 3 minus lower limit 0. You are getting the term like this. So your an is this. You are going to find bn. Your bn is 1 by l, 0 to 2l, f of x sine n pi x by l into dx. Your l is already we have seen 3 by 2, 2l is 3. Then again we are going for Bernoulli's integration by parts. You put 3 pairs of brackets. First you write here 2x minus x square. Here 2 minus 2x. Here differentiate this, it is minus 2. Then in the first term, second bracket, integrate this. It is minus cos divided by 2n pi by 3. Cos integration is plus sine divided by 2n pi by 3 the whole square. I have written it as 4n square pi square by 9. That's it. Again integrate minus sine. It is plus cos because integration of sine is minus. Minus minus it is plus cos divided by 2n pi by 3 the whole cube. I have just cubed it and then I have written it here. So now substitute x equal to 3, 3 getting cancelled, sine 2n pi is 0. Substitute x equal to 0, sine 0 is 0. Apply for the next two, that is first and last term, upper limit minus lower limit children. You are getting the terms like this. So substituting a0, an, bn in 1, you will be getting the required Fourier series. This is for 0 to 2l or 0 to 2 pi or 0 to 6, 0 to 7, whatever it is like that the interval is, you will be finding the Fourier series. Now, we are going to coming across the Fourier series in the interval minus L to plus L. Keep it in mind children. Here we come across 3 types. One is even function, odd function, neither odd nor even function children. Now what is in even function? Keep it in mind bn is 0. For odd function a0 and an are zeros. Okay. So what is even function? If f of x and f of minus x are same, equal, it is an even function. If they differ by a negative sign, it is said to be odd function. Example C, f of x equal to x square. F of minus x is also x square. So it is a even function. But f of x equal to sin x. What is sine of minus x is? Minus sin x. So minus f of x. So f of x and f of minus x differ by a negative sign. So it is an odd function. See here, you take f of x equal to e power x children. F of minus x is e power minus x. So it is neither odd nor even children. Here, in this, we will be coming across this definite integral property. Integral minus a to plus a f of x dx will be twice 0 to a f of x dx if f of x is even. It will be 0 if f of x is odd. Using this only, we are going to see even odd functions Fourier series, right? Now see, we are going to see Fourier series for even function in minus L to plus L. Children, minus L to plus L, whatever it is given here, it is your L here. So see, upper limit minus lower limit by 2 is also L, minus of minus, lower limit is minus L. It is L plus L, 2L by 2 is L. So whatever is given is your L. Okay, now it is, I told you your Bn is 0 here, right? It is f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by L. What is a0 is 1 by L minus L to plus L integral f of x dx. But f of x is an even function. If it is even by this property, it can be written as twice 0 to L. because f of x is even, children. So a naught is 2 by L into integral 0 to L f of x dx. Similarly, your an is 2 by L 0 to L f of x cos n pi x by L into dx, children. If it is bn, why it is 0 is, it is f of x into sine it will come. F of x into sine means it is odd into even. It is odd. By this property it is 0. Okay. Then second one, for odd function, already I have told you here, a naught and an are 0. So in your Fourier series you will be getting only bn sin n pi x by L, where summation n equal to 1 to infinity varies. Where bn is 2 by L 0 to L f of x sin n pi x by L into dx. Suppose Fourier series is neither odd nor even, right? Nothing wrong in it. You write as usual formula like a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L plus summation n equal to 1 to infinity b n sin n pi x by L, right? Here 1 by L, the interval will varies between minus L to plus L, integral from minus L to plus L f of x dx. Everything is the same. Okay, so as usual formula. Here, like, you have to know this, odd into odd function is even. Even into even is even function. Odd even or even into odd is odd function. Now, see example, x is also odd function, sin x is also odd function. Odd into odd, it is coming to be even function. Okay, you have to keep it in mind while doing the problems. Now, first question. Find the Fourier series of period 2 pi for f of x equal to x square in minus pi to plus pi. Hence, deduce that. You have to deduce the 4, what is Emma? Deduction paths. Now, always 1 by 1 power 4 plus 1 by 2 power 4, 1 by 3 power 4 plus so on will be pi power 4 by 90 for all the questions. Because the series value will be the same, right? You can keep all these values in mind while you are finding the values. If it comes to be correct, then you are doing properly, right? You can just have a, what is Emma, conclusion. Yes, we have done it correctly. Likewise, now 1 by n power 4 means for the last part you have to go for Parsevals, right? We'll see f of x equal to x square. Already I hope so we have done it in the first 0 to 2 pi problem also, I hope so. So, but minus pi to pi, what you have to do, ma? Whenever you come across minus L to L or minus pi to pi, minus 2 to 2, you have to go check whether it is even, odd, or neither odd nor even. Now, f of x equal to x square, f of minus x is also x square. So, it is a even function, bn is 0. So, L is pi, isn't it? L is pi, straight away you can take it out. So, your f of x is this. You are going to find a naught. It is 2 by pi, 0 to pi, f of x dx. You have to use this for a naught is 2 by pi, 0 to pi, f of x dx. An will be 2 by pi, 0 to pi, f of x cos nx dx. Likewise, it will be. So, you are evaluating this. You are getting 2 pi square by 3. Similarly, this we have already done in the first part, first question there, right, in 0 to 2 pi. Similarly, you have integrated. You are getting this. Substituting a naught an in the, what is my equation 1, you get the required Fourier series for x square. Now, I have done deduction part 2 first. First, what is your deduction part is, with alternative plus or minus 1 by n square should come. So, what we are doing is, we are taking at x equal to 0, right? At x equal to 0, what will happen? It is a continuous function point, right? X equal to 0 is a continuous point, and then whenever it is in between the interval, it will be always a continuous point. It is not, theoretically it will not be correct. Just I'm giving a hint. You keep it in mind. If it is a middle point, right, in between the interval, maximum it will be a continuous point, right? So it is a continuous point. So f of x converges, sum of the Fourier series equal to the value of the function at x equal to 0 converges to f of 0. So f of 0 is, see, f of 0 is 0 square. So it is 0. So left hand side is 0 at x equal to 0. You substitute x equal to 0, both sides. Left hand side is 0. Cos 0 is 1. You will be getting like this. Apply n equal to 1, 2, 3, so on. you will be getting like this. If you simplify, you will get the second deduction part. First one is everything is positive. So everything should be positive here means only positive possibility is this minus 1 whole power n should be plus 1. So how it is possible if this is also cos and pi? It is minus 1 whole power n. So minus 1 whole power n minus 1 whole power n, it will be minus 1 whole power 2n. So we are going for x equal to pi. It is a end point. So the sum of the Fourier series at x equal to pi is equal to, what is m? 1 by 2 f of minus pi plus 0 plus f of pi plus minus 0. So you are substituting in the left side at x equal to pi, equation 2 becomes, you are simplifying, that is you are putting on the right hand side x equal to pi. Children, unless otherwise it is a continuous point, here you cannot put x equal to 0. Right? You understood? That is the convergence condition I have given. Only at the continuous point, this is f of x, isn't this? Left hand side is. You can, if you are applying x equal to 0 in equation 2, it will become f of 0 only when x is equal to 0 is a continuous point. Here it is not so. So what you are doing, ma? You are going for this pattern as given in the convergence condition for Fourier series. Next to Parseval's identity I have given. So now you apply x equal to pi on both, that is on the right hand side, and left hand side is this. You will be getting, if you simplify, you will be getting pi square by 6. See, next what is the third deduction is? If you add these two, you will get this one with twice on the left hand side, right? So you are adding deduction 1 and deduction 2 for the third one. You will be getting, see, adding, 3 and 4 means deduction 2 I have taken it as 3, deduction 1 I have taken it as a 4. If you add 3 and 4, you will be getting the deduction 3 here. Now whenever 1 by n power 4, you have to go for Parseval's identity. So write the Parseval's identity, substitute f of x, a naught, a n values, right, with square a naught square a n square f of x the whole square. Then if you simplify, you will be getting this pi power 4 by 90 for summation 1 by n power 4. Right? Second one, ma. F of x is equal to x. You have to find Fourier series for it in the interval minus L to plus L. Minus L to plus L, minus pi to plus pi, minus 2 to plus 2. Whatever it is, you have to go for, what is it, ma? You have to check it whether it is odd or even function. Now f of minus x is minus x. That is f of x. And minus, that is f of x and f of minus x differ by a negative sign. So it is an odd function, children. So your a naught is 0. Also your a n is 0 for an odd function. So your f of x comes to be like this. Your bn is 2 by l, 0 to l, f of x sin n pi x by l into dx. Your f of x is x. This is u, this is v. So two pairs of bracket. X, differentiation of x is 1. Here integration of sin n pi x by l is minus cos n pi x by l divided by n pi by l. Here if you integrate this cos, it is plus sin n pi x by l divided by n pi by l. Already minus n pi by l is there. So it is minus 1 by n square pi square by l square. Apply x equal to l. L will be getting cancelled. Sin n pi is 0. Apply lower limit. Sin 0 is also 0. So the second term is 0. Vanishing. So apply the limit for the first term. You will be getting like this. Substituting this bn in 1, you get the required Fourier series for f of x equal to x, children. Then next one is find the Fourier series expansion of f of x equal to sin ax in minus L to plus L, where a is not an integer. Now you are checking for odd or even function validity. It is an odd function. So a naught a n is 0. Only you will be having summation n equal to 1 to infinity bn sin n pi x by l. Your bn integration value is this. You are substituting f of x. We have already come across 2 sin a sin b is cos a minus b minus cos of a plus b divided by 2. Your capital A is ax. Your capital B is n pi x by l. Apply cos A minus B minus cos of capital A plus B here. You will be getting this ax plus n pi x by l. Take x outside, it will be like this. Cos A minus B. Ax minus n pi x by l. You are taking x outside, so A minus n pi by l. So divided by 2. This 2 will be getting cancelled. You have to integrate the two terms. It is cos integration is sine divided by the coefficient of x. Similarly here also plus sine divided by the coefficient of x. In between there is a negative sign. It is as such. Apply upper limit minus lower limit. You are getting like this. L you are applying for x. So if you multiply AL minus n pi. Similarly here also in the denominator you are taking LCM. You are getting terms like this. This L in the denominator it is going to the numerator, right? So LL is getting cancelled. You are getting as such. Now take LCM. Okay, do one thing. Expand sine A minus B. Sine A cos B minus cos A sine B. Here it is again sine A. Here it is plus children. Here it is. Here it is plus. Sine of A plus B, isn't it? Sine A cos B plus cos A sine B it is. So you are expanding it. Sine n pi is 0. Cos n pi is minus 1 whole power n. You will be getting as such. Okay. Take sine AL into minus 1 whole power n commonly outside. In the denominator, it is A plus B into A minus B. A square minus B square. That is A square L square minus n square pi square it is. So you will be after in the first term it is AL plus n pi minus second term AL minus n pi because you are taking the sin AL minus 1 whole power n, that is minus 1 whole power n into sin AL commonly outside. Remaining term is your Bn. Substitute in 1, that is f of x. This is your Fourier series. Then next question, fourth question is you are going to find the Fourier series for f of x equal to x square plus x in the interval minus pi to plus pi. See, so, replace x by minus x. It is coming to be x square minus x. X square plus x it is f of x is f of minus x is x square minus x. So they are not equal or they are not the same or they are not differing by a negative sign. So neither odd nor even. So your function will be like this. You have to find all a naught, a and b n like this. A n is 1 by pi minus pi to plus pi f of x dx. You are integrating x square plus x. Substituting upper limit minus lower limit. You are getting a naught as such. A n is 1 by pi minus pi to plus pi f of x cos n x dx. Again u v. See x square if you have put 3 pairs of brackets. First here x square plus x. Here differentiate this, it is 2x plus 1. Again differentiate this, it is 2. Integrate cos n x, it is sin n x by n. Integrate sin, it is minus cos n x by n. Already 1 by n is there, so 1 by n square. Again you integrate cos n x, it is sin n x by n. Already minus 1 by n square is there, so minus by n cube is added to it. As usual, upper limit minus lower limit. Sin n pi, sin minus n pi is also minus sin n pi. So both are 0 first term and last term. For the middle term, you are applying the upper limit minus lower limit. Your an is this. Again, you are going for bn 1 by pi minus pi to pi. F of x is x square plus x sin x nx. Here 3 pairs of bracket because x square. So first x square plus x, it is 2x plus 1, it is 2. Here v1, you have to integrate this minus cos nx by n. You integrate this plus sin nx by n, already minus 1 by n is there, so minus 1 by n square is added. Now integrate this, it is sin integration of sin is minus cos nx by n, minus or minus plus by n square is there, so by n cube. Apply upper limit minus lower limit, sin nx will be getting 0 for upper limit as well as lower limit. You are applying the limit, upper limit pi, right, wherever it is x, then lower limit minus pi wherever it is x, then you are getting your bn value to be like this. Substitute in this. Even you take it as a homework also. Even you can deduce summation 1 by n square here, which is nothing but pi square by 6. That is, this should exist, this should vanish. Okay, 1 by n square is there. So 1 by n should not be there. Likewise, you have to choose your x. Try to do it. Then f of x here, splitted interval f of x is, it is minus x in minus pi to 0. It is x from 0 to pi. Whenever it is minus pi to plus pi, you have to check whether it is odd or even. Find f of minus x. Wherever it is x, replace it by minus x, children. Now it is minus of minus plus x. Here it is minus x as such. Here also you have replaced x by minus x, isn't it? Multiply throughout by minus 1. When you are doing so or dividing throughout by minus 1, the inequality will change. Plus pi greater than plus x greater than 0. Here 0 greater than x greater than minus pi. Likewise it is. Rewrite this. This is nothing but your f of x. See, x from 0 to pi. X from 0 to pi. Minus x and minus x to 0. Minus pi to 0. See. So f of minus x and f of x are the same. So they are, that is, f of x is an even function. Your bn is 0. Your L is pi. Your L is pi. So cos n x, sin n x, likewise it will be. So a naught by 2 plus summation n equal to 1 to infinity a n cos n x. Again a naught is 2 by pi, 0 to pi f of x dx. Substitute your f of x. 0 to pi, what is your f of x? Right? It is easy. 0 to pi, what is your f of x? You are substituting it to be x. Integrating it. Your a naught is this. A n is 2 by pi, 0 to pi f of x cos n x. Your f of x is x. UV, 2 pairs of bracket. If it is x, 2 pairs of bracket. X square, 3 pairs of bracket. X cube, 4 pairs of bracket. That's it. So now x, differentiate x, it is 1. Cos n x, sin n x by n, integration is. Again integrate, minus cos n x by n square. The sign will be getting vanished for pi n 0. If you substitute pi n 0, it will be sin n pi sin 0. So it is 0. Apply the limit for this. You will be getting like this. Cos n pi is minus 1 whole power n. When n is even, what will happen, ma? This will become plus 1. 1 minus 1, it is 0. When it is odd, this will be minus 1. Minus 1 minus 1, it is minus 2. So minus 4 by n square pi it is. Likewise it comes on. Substitute a naught a n in f of x. Your deduction part is, what is your first deduction? Only one. All, what is it? Summation n is odd, 1 by n square. So it is this you should have with cos should be 1. Then it is easy. You are taking x equal to 0, which is a point of continuity. When x equal to 0, 2 becomes. I told you if it is a continuous point, you can apply x equal to 0 on the left hand side. F of 0 it is. So f of 0 is 0. See here, f of 0 where it is f of 0. It is 0 here. Or if you take here also, it is 0. So you are getting left hand side to be 0, right side cos 0 is 1. You simplify, you will be getting the answer. Now ma, in minus pi comma plus pi, find the Fourier series of periodicity 2 pi for f of x to be like this. Again minus pi to plus pi. What you have to go for? You have to go for whether it is check. You have to check whether it is odd or even. F of minus x you take. Wherever it is x, put minus x, minus x, minus x, minus x. So it is coming like this. Take minus outside in both the cases. Here it is minus x, minus x. If you multiply throughout by minus or divide throughout by minus, the inequality will change. So 0 greater than x greater than 0, it will be uh, here 0 greater than x greater than minus pi, it will be here. Pi greater than x greater than 0, it will be. Rewrite, take this negative commonly outside, it is minus f of x. So the f of x and f of minus x differ by a negative sign. It is an odd function. So a naught and a n are 0. So your f of x is like this. So you have to find only bn here and substitute. Bn is 2 by pi, 0 to pi f of x sin n x dx. Your bn is from 0 to pi, what it is? From 0 to pi, it is 1 plus x. Apply that. Okay. Apply that. So uv. X is there. So 2 pairs of bracket, 1 plus x. Here if you differentiate, it is 1. You integrate this and put here minus cos n x by n. Integrate this minus sin n x by n square. The second term will be becoming 0 because sin n pi sin 0. It will become after applying the upper limit and lower limit. So after applying the limit for the first term, you will be getting the terms like this. Substitute in 1. This is your Fourier series for what is a given function. Then This is very important, children. Find the Fourier series for f of x for mod cos x. Again, this is a even function, right? Cos of minus x itself cos x. So modulus, again it is plus, it is a even function. So Bn is 0. Your f of x will be like this. Your a0 is like this. But you all know, if you are plotting y equal to cos x, at x equal to 0 it is 1. At x equal to pi by 2 it is 0. X equal to pi it is minus 1. Cos pi is minus 1. Right? Likewise it goes on. So what will happen? From 0 to pi by 2 it is positive. Pi by 2 to pi it is negative. So mod cos x is defined like cos x in 0 to pi by 2 minus cos x from pi by 2 to pi, children. So you are splitting 0 to pi as 0 to pi by 2 plus pi by 2 to pi. 0 to pi by 2 it is cos x. Pi by 2 to pi it is minus cos x. Integration of cos x is plus sin x. Applying the limit, you will be getting like this. Sin 0, sin pi are 0. But sin pi by 2 is 1. You are getting a0 to be like this. Similarly, an is 2 by pi, 0 to pi, f of x cos n x dx. 0 to pi by 2, pi by 2 to pi. It is splitted as 0 to pi by 2, f of x is cos x. Here it is minus cos x. Again, we have take this 2 inside 2 cos x cos n x. Again, here also 2 cos x cos n x. You take it. Take this negative to before the integral sign. 2 cos a cos b formula you apply. A equal to nx, b equal to x you take. You will be getting cos of a plus b plus cos of a minus b. Similarly, here also the same term. You will be getting. So what it is? You are going to integrate it. Cos integration is sin n plus 1 into x divided by n plus 1. Here also sin n minus 1 into x divided by n minus 1. Same integration here also, but the limits will vary. 0 to pi by 2, pi by 2 to pi. Now you are applying the limit, right? Here the lower limit sin zeros are 0. Here the upper limit sin n plus 1 into pi or sin n minus 1 into pi also 0. Not only sin n pi, anything multiplied by pi is 0, sign off. So you are getting as such. Now you take this sin n plus 1 into pi by 2, multiply it inside. Sin a plus b. What is sin a plus b? Sin a cos b plus cos a sin b, children. Cos pi by 2 is 0. Sin pi by 2 is 1. So you'll be getting this to be cos n pi by 2. You take sin n minus 1 into pi by 2. Multiply inside pi by 2. You will be having sin of a minus b. Sin a cos b minus cos a sin b. Again sin pi by 2 is 1. Cos pi by 2 is 0. This is 0, children. This is 0. So you will be getting only minus cos n pi by 2. Substitute here. Simplify. You will be getting like this. Right? You will be getting like this. Then here you have one thing, children. What it is in this denominator n plus 1 into n minus 1, it is coming to be a square minus b square, n square minus 1. You substitute n equal to 1, what will happen? 1 minus 1, it is 0. Anything by 0 is infinity, children. Anything by 0 is infinity. So what you have to do is, you people have to find a1 separately. So what is a1? Wherever it is n, you do one thing. You apply 1 here. a1 is 2 by pi, 0 to pi, f of x, cos 1x dx. See here, ma. Cos 1x dx. You are substituting. Again, you are splitting the 0 to pi as 0 to pi by 2 and pi by 2 to pi. Again, 0 to pi by 2 it is cos x. Pi by 2 to pi it is minus cos x, children. It is, take this 2 inside. It is 2 cos square x. 2 cos square x it will be. What is 2 cos square x is? 1 plus cos 2x. Apply it. Then integrate. You will be getting 1 integration is x. Then here cos 2x is sin 2x by 2. Apply upper limit minus lower limit. Simplify. You will be getting it as to be 0. Substitute a0, a1, an in 1. So here a1 cos x plus n equal to 2 to infinity an cos nx it should be. Right. So a1 is 0. You are substituting here. From n equal to 2 to infinity you are applying this. N is not equal to 1. Right. Likewise. Then f of x equal to 1 plus 2x by pi in minus pi to 0. 1 minus 2x by pi from 0 to pi. Even deduction part is given. what you have to do is take f of minus x. Wherever it is x, you put minus x. So here it will be minus, here it will be plus, here it is minus, here it is minus, it is coming to be. Then reverse by multiplying by minus 1, reverse the inequality. You will be getting it to be f of x. So it is a even function. Bn is 0. A0 is 2 by pi, 0 to pi f of x dx. Integrate this f of x, right? And then your A0 is coming to be 0. Your An is 2 by pi, 0 to pi f of x cos n x dx. 0 to pi, what is your f of x? It is 1 minus 2x by pi. That only you are substituting here and also here. This is u, this is v. So 2 pairs of bracket because only x. So 1 minus 2x by pi. Differentiate this, it is minus 2 by pi. Again, integrate cos n x, sin n x by n. Then again integrate sin n x by n, it is minus cos n x by n square. Apply the limit, you will be getting like this. Again, when n is even, 1 minus 1, it is 0. When n is odd, minus 1, it is minus 2, into minus 4, it is 8 by n square pi square. You are substituting the value, your f of x is this, right? You have to find the deduction part to be 1 by 1 cube plus 1 by 3 cube plus 1 by 5 cube plus so on. All the odd values square in the denominator. So what you are doing is you are taking 0, which is a continuous point. When x equal to 0, left hand side will become f of 0 because x equal to 0 is a point of continuity. Cos 0 is 1. You simplify, you will be getting the answer. Final question mark. Find the Fourier series expansion of f of x equal to 1 minus x square in minus 1 to plus 1. Your L value is minus 1. Check for even odd condition. So f of minus x is 1 minus of minus x the whole square. Again, it is f of x even function. Bn is 0. Here f of x will be a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by L is 1. So by 1 it is. Similarly, 2 by 1, 0 to 1 f of x dx. F of x you are substituting, integrating, you are getting it to be like this. An is also 2 by 1, 0 to 1 f of x cos n pi x by 1 dx. Again it is uv. X square, so 3 pairs of bracket, 1 minus x square. Differentiate 1 minus x square, it is minus 2x. Differentiate it, again it is minus 2. Integrate this, it is coming to be sin n pi x by n pi. Again integrate this, it is minus cos n pi x by n square pi square. Again integrate this, it is minus sin n pi x by n cube pi cube. So whichever is coming to be 0, like sin n pi sin 0, just cancel it. Apply the limit, you will be getting your an value to be like this. Substitute your a0, an in 1. We get the required Fourier series, children. In the description, you will be having the notes. Kindly just refer that. Thank you.